Hi, my name is Zhuo Xi, and my wireless communication project's name is Realization of OFDM System. First is the introduction part. The common digital modulation such as PSK and QAM can just transmit signal by a single carrier. That way is waste bandwidth and the transmit rate is very slow. And that way second will cause interference in channel. That means the bit error rate is very high. But OFDM can overcome this drawback. OFDM is a multiple auxiliary subcarriers and they are overlap with each other. And the whole transmission part is parallel. So that means that all the subcarriers share in one common band. And the OFDM has very high spectral utilization. And but also, multiple path transmission always has two problems. First is inter-signal symbol interference, which is ISI, and second is frequency selective fading, that is FSF. Because of narrow band channel of OFDM can avoid these two problems. OFDM can choose the simple rate in order to keep symbol interference at a low level, and the perceptive of fatness can solve the problems of FSF. So OFDM is a very effective way. And here is the process. First is the transmitter part. First, we need to convolutional code that make the 1/2 rate convolutional encode is used as a standard coding channel in case of error rate of the system increasing. And then is interleaver part. And the interleaver is presented in the form of maxim. And input data was rearranged by this, and resulting that consistive and whole data are spared into the various block. And then we have the modulation part. And we can plot the function of one modulator, a signal constellation-based complex members which are transformed by the corresponding set of bits. And especially S and R is a direct proportion to streams. Higher S and R means the subcarrier can process more bits. And then we go to IFFT part. And the IFFT part is the transform data from the frequency domination into time domination. And all the subcarriers can translate into the corresponding point of the IFFT. And the next part is CP, because perfect is a copy of a frame last element. We intended to add this part in order to perceive the oscillatility property of the signal, whose useful part can be handled after processing. And then the last part is the DA, in order to transform digital symbol into analog version. And then it's the channel part. And after the signal passes the channel, we get the receive part, and the receive part is just a reversion. It's a reverse of the transmitter. The first is AD, and then is synchronization, and then is the removed CP, and then we use FFT, and there is the channel estimation and the bit loading. So this is the whole diagram of the OFDM. And here is the principle of OFDM. O in OFDM means oxygen, which means that carriers are oxygen with each other. So let's take a simple example of sine of t and sine of 2t. So as we know, the equation here is sine of t times sine of 2t. We make this operation, they equal to 0. And we can first take the sign of t as first character, with transmission signal is xt equal to a. And let's take the signal 2t at the second carrier, which transmits the signal y of t as b equal to b. And then we can send the signal like this as a times sine of t plus b times sine of 2t. And the receiver will get the transmission signal decoding, and then decoding it use the sine of t and sine of 2t separately. So this equation, we get sine signal x of t equal to a. And use the equation here, we can demodulate, we can decode the signal y of t equal to b. And then we can enlarge the carrier set from the two sine signal to the k pair of carriers, which you can see here is sine and cosine. And then here is the multi-carrier system in the time domain. As you can see that we have the k input, and when we modulate it, and then we go to the channel, and then we demodulate it, and it's also returned to the k signal. And this is the frequency specters of the OFDM. That you can say that is frequency of sine of t, and that frequency of sine of 2t. That means that the frequency of the carrier can for free the whole spectrum, which can make the multiple carrier system done. And here is the result of transmitter. First, we should make sure that FC is the center of the spectrum of OFD system. And based off this table, we consider used IFFT, whose n is equal to 2048 to realize centering. So I choose n equal to 4096 IFFT. And then we design the simulation period. Based on Nyquist criterion, we choose RS equal to 19 MHz as the frequency of carrier. And in order to realize oversample, I insert 2391 0 point into the 4QAM symbol. So you can see this is the time response of the signal, which is shown here, and this frequency response of the signal. You can see the signal is here. Then we need to transmit this signal. And in order to simulate the drawback of OFDM, I generate the disturbing signal in continuously time domain. Like this. This is noise. And then I put the signal, which is a noise, add the original signal into the Butterworth filter. You can see the Butterworth filter is like this. And then we get the output. This is output signal of frequency in time domain, and this is output signal in frequency domain. It shows aliasing because NFFT is used in OFDM. So in order to avoiding aliasing, we should use a cutoff. So we set 1/t is the cutoff frequency of the filter, and I adding the roll-off signal, which is here, into the output signal. So you can see the signal just turn this. This is the signal in time domain, and this is the signal in frequency domain. And then I will make OFDM modulation. I use a formula of this. So you can see this is the real part of cosine is here. Show here. This picture show this part, and this picture show this part. This is the this picture show this part, and this picture show this part. So it's this real part, and this is IM part. Then this is the time response of ST. The equation ST, it looks like this. And this is the frequency response of ST. It looks like this. And then we go to the receiver part. And actually, the FDM receiver precision is just the inverse version of transmission. So it says here, we have the 5 block, and A, B, C, D, E means each output. The first signal in time domain is the AD is actually the AD part, and then this is the signal A in time domain. This is signal A in frequency domain. Then I need to turn it into the signal B. The output B is here, so you can see the signal B time domain and signal B in frequency domain, and it is a continuously signal in order to turn it into the discontinuously signal. So this is the we should put the B into the block C, and then we have the outcome. You can see here is signal C in time domain, and this is the signal C in frequency domain. Spectrally, this output should equal to the input signal here, because it is the transmit, it's the result of the whole system, and then we make it into FFT, and we can see the output D and the output of E. And output E show that there are 4 channel inside the system, which means that the whole project is successfully done. And here is the MATLAB code that I can show all the picture I get from the code. First is transmission part, so I run it. You can see the old picture. There are 10 pictures just as this. So this is I copy from the result, the picture I get from the code. And that code shows the transmission part. And then I go to the receiver part, and I run it. You can see the output here. This should be similar as with the input signal, and then here we show the 4 channel of the whole system. And make a conclusion that I realize OFDM and make creativity that we do not need to insert equalization mode in the system. And among all of OFDM standards, TVBT mode has a better performance in terms of BER versus SNR. In addition, in addictive in the white Gauss noise and in FE channel. And OFDM is a traditional multi-pass modulation of transmission, which has a good members of advantages, but we still have many problems need to solve in order to improve it. And that is all my demo of my projects. Thank you.